Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and this video is number 8 in a series of lecture videos on complex numbers. Let's continue. Yesterday we talked about e to the power I, and in general we talked about trigonometric functions such as sine and cosine, and we came up with formulas, right, for sine and cosine. And then just by using Euler's formula we evaluated e to the power I, and that just happens to be cosine 1 plus I sine 1, of course 1 radians, not degrees. Now today we're going to talk about some other problems. There's actually two things. The first one is going to be finding tangent theta, and now we're going to talk about something else. You'll see in a little bit. Now how do you find tangent theta? Well, we have formulas for sine and cosine. Remember them. Sine theta can be written as e to the power I theta minus e to the power negative I theta divided by 2i. Remember, we subtracted those equations and then divided by 2i, because remember e to the power I theta was cosine theta plus I sine theta, and e to the power negative I theta is just this, the conjugate, and then you just kind of work with them. And cosine theta would be e to the I theta plus e to the negative I theta divided by 2. So I got cosine and sine. How can I find tangent from there? That would be a fairly easy problem, right? It's not even a problem. It's just kind of like an exercise, hopefully. So let's go ahead and find it. And later on, we're going to solve some interesting problems that uses these identities. So tangent theta from trigonometry, you hopefully know that sine theta over cosine theta is equal to tangent theta. So we can just go ahead and plug it in. This is going to be e to the I theta minus e to the negative I theta divided by 2i. And since I'm going to divide two fractions, why not multiply by the reciprocal, which is going to flip the second one and give me this. All right. So this is the value of tangent, but can we simplify this a little bit? At least a little bit, right? Let's go ahead and get rid of the 2. And then tangent theta from here is going to be this divided by that times I. But obviously you don't want to keep that I, and you want to multiply actually the top and the bottom by negative I. And sometimes people are confused why I'm using negative I, because I want to get a positive one, because I times negative I is negative I squared, and negative I squared is equal to positive 1 because I squared is negative 1. Remember, one thing that you should never forget with complex numbers is that I squared is always, always, always negative 1. Okay? One takeaway from every video, hopefully. So now we can basically forget about this. So we have this left, but something will be multiplied by negative I, which means it's going to be kind of negated. So I can write it like this. I times e to the negative I theta. Notice that I need to switch these. Minus e to the I theta divided by e to the I theta plus e to the negative I theta. Make sense? And that's going to be my tangent value. And notice that tangent theta is kind of like a multiple of I. So if I say, hey, if tangent theta is equal to I, can you solve for theta? And the answer is, let me not answer it. You go ahead and find out. Or if tangent theta is equal to 1/2 of I, can you find theta from here? That will be a good exercise. Just use the identity and solve the quadratic equation that results. Make sense? Hopefully. Great. If not, please let us know in the comment section down below. The next thing we're going to do today is solving quadratic equations. I mean, not necessarily with real coefficients, but with complex coefficients. So let's take a look at this one. Remember, we started this series with a quadratic equation and then solved it, and we needed a number whose square equals -1, and that's how we came up with the I. I mean, we didn't, but pretend we did, kind of for the excitement of it. Anyways, so let's solve this problem. We have two options here. Either use the quadratic formula or completing the square. I like completing the square if you really ask me about it, because it's fun, but how do you know what to add, right? So anytime you have something like x squared plus bx, what do you add to make this a perfect square, right? That's a perfect question. And this is what you need to do. What is this coefficient? B. What is half of b? B divided by 2. If you square it, what do you get? B over 2 squared. What is that equal to? B squared over 4. That's what you need to add. Exactly. So take the coefficient of x, cut in half, square it, and that's what you got to add. So let's apply it here. What's the coefficient of x? Negative 2i. What is half of negative 2i? It's negative I. What is negative I squared? It is the same as I squared, which is negative 1. So I'm supposed to add negative 1 to both sides. Wait a minute. Are you sure about that? No. We're not going to add negative 1. We're going to add I squared to both sides, as if it's different. But we're going to do that because it looks better. Now I'll show you why it looks cooler. So left-hand side, if you take a look at it, take a good look, this is a perfect square. It is x minus I squared. Awesome, right? That is equal to 1 plus I squared. I squared is negative 1. Wait a minute. Isn't this 0? Yes, it is. So set it equal to 0, and guess what? You only get one solution from here because x minus I equals 0 is the only result, and x equals I is going to be the only solution. Can a quadratic equation have a single solution? Yes, because if the discriminant is 0, is the discriminant 0? I didn't really check it, but it should be, hopefully. Anyways, let's take a look at another equation. This equation is kind of more interesting because we have more numbers, more coefficients, and this time we have a complex constant. Nice. But you know how to solve quadratic equations. This is not factorable. Completing the square, I don't think so. Because the coefficient of x is odd. You see how odd that is? You don't want to do that. Evens, yes, you may. Anyways, quadratic formula works. Who cares? Quadratic formula tells me negative b plus minus the square root of b squared, which is 9, minus 4ac. A is 1, so we don't care. 4c, 4 times 3 minus I. This is the fun part, and divided by 2i. I mean 2a, not 2i. Okay, been thinking about I all this time. So now, let's go ahead and simplify this. How do we simplify this? We need to distribute. Let's do it. X equals 3 plus minus the square root of 9 minus 12. That's going to be a negative 3, and then plus 4i. Awesome. And then that's divided by 2. Now, is that the answer? Yes and no, because you want to simplify the stuff under the radical. What does that mean? We have to find the square roots of this complex number. But plus minus sign is going to give us two options anyway, so we can just find one of the roots and it'll work. How do you find the square root of, I'm just referring to one of them, by the way, because there's no single square root. But how do you find one of them? Well, there's a couple different options you can use, but one of the methods that we use, I don't know if you remember that, but setting it equal to, where does the 2 come from? Who knows? Setting it equal to a plus bi and then squaring both sides. That's going to give me a squared minus b squared plus 2abi. Hopefully, you know what I did. Bi squared is negative b squared. And then from here, you can quickly come up with a system. A squared minus b squared is equal to negative 3. And 2ab is equal to 4, which means ab is equal to 2. Great. So you're going to find two numbers whose product is 2 and whose sum of squares equals negative 3. I think those numbers are 1 and 2 because it's not going to work the other way around because this is not symmetrical, but a equals 1, b equals 2 is going to work. Therefore, one of the square roots is going to be 1 plus 2i. Make sense? This is one of them. The other one is the opposite, but plus minus will take care of it. Let's go ahead and plug it in. This was, what was the answer? 1 plus 2i, but put it in parentheses so negative can take care of it. And now let's go ahead and distribute and look at each case, right? Let's go ahead and clean up a little bit here, because you already got this, hopefully. And by the way, in case you didn't get it, this is the channel. Go ahead and make sure you subscribe and comment and do all kinds of good things. Okay, now one of them is going to be 3 plus 1 plus 2i divided by 2. It's going to be 4 divided by 2, 2i divided by 2, 2 plus I. That's one of the x values. The other x value is just going to be 3 minus 1 minus 2i over 2. That's 2, that's 1, that's minus I. So those are going to be the x values that are two solutions. And this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time. Hit the notification bell. Stay tuned for upcoming videos. And see you in the next episode. Bye.